Naming simple organic compounds is certainly one of the skills that we'd like you to have. Let's look at the names of ethers. A lot of common names again, but it's primarily the IUPAC names that we'd like you to be able to come up with. Here's the structure of an ether. 3 carbons on this side, 1 carbon on that side. The oxygen bridge in the middle is what makes it an ether. The IUPAC system, taking the rules one at a time, emphasizes the longest chain as the base word, the longest carbon chain, we should say, or sometimes we have a ring that would form that base word. 1 carbon on this side, 3 on that side. This side is going to form the base word for our IUPAC name. Can't number through the oxygen. And then once we've established the longest chain, we're going to number it to get the lowest number for the position of any groups attached. Or another way of saying that is to number from the end closest to the group. That means that we'll number this chain in this manner. At position 1, we have this group of atoms. And so we've got to come up with a name for that group. Then we're going to attach it to the rest of this. This would be propane. Over here, the OCH3 is called an alkoxy group because of the presence of the oxygen. This is a methoxy, changing the YL to an OXY. You could have a 2-carbon group attached to an oxygen. That would be ethoxy, propoxy, and isopropoxy. Those are the ones that we'd like you to know. We wouldn't go up to the 4 carbon groups. So the name for this compound would be 1-methoxypropane. Let's look at another example. Whenever you name an organic compound, you look for the presence of the functional group, and that tells you what the ending of the name is going to be, or what kind of procedure you need to worry about. Here I see an oxygen located between 2 carbons. I'd say to myself, hey, it's an ether. The longest carbon chain is 4, so butane is going to be the base word. We'll number the longest chain from the end closest to this branch. That means that we'll number from the right-hand side up there. At position 2, we have a 2-carbon group attached to that oxygen. So it's going to be an ethoxy. 2-ethoxy butane would be the name. Here I've got a cyclic structure. And it would be easiest for us if the ring were part of the base word. So cyclopentane is the base word. Then attached to it, 3 carbons on the oxygen. It's an isopropoxy group because it's attached to the middle carbon. If it were attached to one of the end carbons, it'd be propoxy, but this one is isopropoxy cyclopentane. Don't have to put the 1 in, it'd have to be at position 1. Let's look at one more example up here. This cyclic structure has a circle in the middle. That means that it's a benzene derivative. I've got an OH up there, so we've got a phenol. Here's another functional group, 3 carbons with an oxygen attached. Phenol will be the base word. And then at positions 1, 2, 3, at position 3, I have a propoxy. This time it's attached to the end carbon of the 3. And 3-propoxy phenol would be the complete name. Or with benzene compounds, there's often another way that you can name them that's IUPAC acceptable. When groups have the relationship of 1 and 3 to each other, and again, this was position 1 up here because the base word is phenol. That made this position 3. But when 2 groups are 1 and 3 to each other, we can call it a meta or simply M. M-propoxy phenol.